This is 7th grade, lesson 26, module 6, on volume of composite three-dimensional objects. All right, so we're going to take care of some volumes here. So let's just imagine we were going to fill up this whole container here. How much water would it require? Okay, so first thing I want to do is we see that we have a top box and we have a bottom box. So I would find the volume of the top box, then the volume of the bottom box, and then put them together. Just add them up. It would be the easiest way than trying to put all this together into one formula. So sometimes it is easier to just go ahead and split it. So we're going to say volume equals the top plus the bottom. So let's find the top first. My top is going to be volume equals length times width times height, and that's because we're dealing with rectangles. So I have 4 times 5 times 5. So I'm going to say volume equals 4 times 5 times 5. And that will give me 100 meters cubed. All right, now let's find the volume of the bottom. And again, we're going to use the same formula. Volume equals length times width times height. All right, now this one you have to fill in some stuff here because I have a height here of 3, but these numbers here are partials, and that's because part of it is behind this image. So what I did was it was actually easier to go ahead and just kind of draw this in for myself so I could see that 3D image and see how much of this I was missing. All right, now if this side here is 4, that means this down here is 4. So 4 plus 6 actually gives me a 10 over here on this end. And then this one here up here is 5. That means this down here is 5. So the 5 and 5 also give me a 10. So my numbers are 10, 10, and 3. So that's what I'm going to multiply together. I'm going to say 10 times 10 times 3. And that's going to give me 300 meters cubed. All right, so now we're going to go ahead and combine these together by adding them up. So I'm going to say my final volume is 100 plus 300. So my volume equals 400 meters cubed. And that's it. Box that, box this, and box that. All of those are answers that need to be looked at. All right, let's go ahead and keep going. Some of these you've actually seen before because we did them when we were solving for surface area. Just now we're going to fill them up with water. So we have this T-shaped container. And if we fill this up with water, first thing I want to do is find out how big is this back piece and then how big is this front piece. Okay, now in order to do that and then find the volume, if I find the area of both of these, then I just add them together and that finds the full volume. So let's try this out. We're going to go ahead and find the area of the back. And that's going to be 2 times 10. And that's going to give me 20 inches squared. And then if I take the area of the front, area of the front piece, that's going to be 6 times 2, and I get 12 inches squared. So to find the full area, I'm going to go ahead and say 20 plus 12 gives me 32 inches squared. All right, so that's how big all of this is. Now, let's find the volume, okay? So I needed this answer, and now I have the full answer. So I know how big the outside is, or I should say the inside, because it is area. We didn't find surface area. Now I'm going to go in and find that volume piece. Okay, so we added those up to give me the area. So now I'm going to say that my volume is going to be 9 times 32. And the 9 I got from the height. We haven't included that 9 yet. 9 times my base times, or my length times width, basically, right? My area. And that gives me a grand total of 288 inches cubed. That is my final answer for that one. All right, let's keep going. Now, this is one of those ones where you want to break it apart. Okay, you should be able to see that we have a couple different shapes in here. We have a rectangle and then we have a triangle. Now, this says that the right trapezoidal prism is composed of a right rectangular prism joined with a right rectangular prism. Find the volume of the right trapezoidal prism shown in the diagram using 2 different strategies. So I'm going to show you one strategy and then I will grade you on another strategy. So I want to show you how to solve it and then I want you to go back and tell me what's another way you could have done this, okay? So my strategy is to break it apart into 2. I'm going to say volume of the rectangle first. And that's going to be volume equals length times width times height. So that's going to be 3 times 2. And then the height's way over here, but I can put it over here. It's 1.5. So we're going to say 3 times 2 times 1.5. That's going to give me 6 times 1.5. 6 times 1.5, you could say 1.5 as well, but that's going to give me 9 centimeters cubed. So there's one answer. Now I'm going to go and find the area, or excuse me, the volume of the triangle. And as you know, volume of a triangle is going to be half my length times width times height. So we're going to say half of 3, because we need this base right here, which is 3, because it's right there. So 3, and then 2 1/4, and then 1 1/2. We're going to put all those together. And I'm going to go ahead and just write that out in parentheses. 3 times 2 1/4 times 1.5. Now, since none of these have repeated decimals, I don't mind going ahead and transferring those into decimal. So we're going to say 3 times 2.25 times 1.5. And when I multiply that inside, I'm going to get, I'll just move it over here, half times 10.125. Now, as we know, fractions just mean to divide. So 2 goes into this number, 5.0625, which gives me the fraction of 5 1/16 centimeters cubed. Now, if you don't know how to take a decimal like this and turn it back into fraction, then I would avoid doing this step right here because you do want your answer to be in fractional form. Okay, so to finish this all up, we're going to go ahead and combine these together. So total is going to be 9 plus 5 1/16, which is going to give me 14 1/16 centimeters cubed. And there is my other answer. So here are all the answers I needed to box. Those 2 and then my final. All right, so what you're going to do is tell me another strategy that you use to you could also use to solve for this. That'll be one that I grade. Next one, example 2. All right. So we have a triangle here that has a hole going from one end to the other on the inside, and the hole is also a triangle. So we're going to find the volume of this one. And then again, it says 2 different strategies, but on this one, we'll just do my strategy. I just wanted you to find the strategy on that first one just to get you thinking. But this one, you can ignore this part. All right, so the first thing I would do is find the volume of the larger triangle. And by doing that, I'm going to say half length times width times height. So that's going to give me half. I have 3 times 4 times 4.5. So 3 times 4 times 4.5. And that's going to give me half times 54. And then 2 goes into 54, leaving me with a volume of 27 centimeters cubed is my larger one. Now, if I find the volume of this smaller one, then what I can do at the end is just combine them. So now let's find the volume of the small triangle. And again, I'm going to say volume equals half length times width times height. I'm going to put my work over here. I'm going to say half of 1.5 times 2 times 4.5. That's how deep it goes back. So we're going to say 1.5 times 2 times 4.5. All right, that's going to be 1/2 equals 13.5. All right, now fractions just mean to divide. So 2 goes into 13.5. And that's going to give me 6 3/4 centimeters cubed. All right, now we're going to combine those up. So we're going to say 27 plus 6 3/4 is going to give me 33 3/4 centimeters cubed. All right, so all the boxings here of all the numbers I needed in order to solve that out. All right, you guys are going to do example 3, A, B, C, and D. Do your best, try your best. Okay, it is going to challenge you, but what they did was they took this problem. I'll just kind of walk you through it real quick. They took this problem and they broke it into sections to kind of guide you through it. So you have a box with a length of a 2 by 1.5 by 1.25. So it's a rectangular box. Okay, so this is kind of like if you've ever bought a TV and then you get it out of the box and there's all that styrofoam. All right, so you have this box, it's that big, and then it's packed into a larger box. That way it can have the styrofoam cushioning, and the styrofoam goes all the way around the box. So you're going to find what are the dimensions of your larger box. I'm going to go ahead and help you with this. Each of these dimensions is going to be a half an inch bigger, and that's going to incorporate the 3 inches all the way around. So your length will now be 2.5. Your width will now be 2, and your height is now 1.75. And that's because they all increased by 0.5 inches to incorporate that 3-inch gap for the styrofoam. So on here it says, design the styrofoam right rectangular prism that could be placed around the box to provide cushioning. In other words, give me the dimensions. What dimensions are you going to use? So how much is needed in the front, the back, the sides, the top, the bottom? What are the dimensions needed? And then you're going to find the volume of all the sides. The volume of the front and back, the volume of the left, right, and the volume of the top, bottom. Okay? Then at the very end, the volume is for C. Then at the very end, for D, you're going to put those all together and tell me how much styrofoam will be needed. All right, so try your best on that one. That one might take you a little while, but give it a shot. And so that ends this video tutorial.